Glass is everywhere. Every screen you look at, every window you look through, every bottle, every lens, every light bulb. It is one of the most versatile materials in human history. It is also, at its core, melted sand. That is the thing that gets people. The most transparent, precise, and optically perfect material we produce is made from one of the most abundant and ordinary substances on Earth. You just need to get it hot enough. And the first humans to figure that out did not do it on purpose. Before humans made glass, nature had already made it. Obsidian, volcanic glass, formed when lava cools rapidly, was one of the most valuable materials in the prehistoric world. Ancient humans were trading obsidian across enormous distances more than 100,000 years ago, long before anyone had thought about making glass deliberately. Obsidian is glass. It forms the same way human-made glass forms. Silica melted at extreme temperature and cooled so quickly that it solidifies without crystallizing. The result is a smooth, dark, non-crystalline material with edges sharper than almost anything else in nature. Ancient humans had been working with natural glass for tens of thousands of years before they made their own. The properties of glass, its hardness, its edge, its translucency, were not unknown to them. They were deeply familiar. The first human-made glass appeared in Mesopotamia and Egypt around 3,500 years ago, roughly 1500 BCE. And like alcohol, like iron smelting, like so many of humanity's most consequential discoveries, it almost certainly happened by accident. The leading theory is that glass emerged as a byproduct of other high-heat crafts. Faience, a glazed quartz material used for beads and decorative objects across the ancient Near East, was being produced in Egypt and Mesopotamia well before glass itself appears. The glassy coating on faience is essentially a primitive form of glass. Someone working with faience, or with copper smelting, or with pottery, produced something different in their furnace. Something that had flowed, cooled, and solidified in an unexpected way. Glass beads are the earliest confirmed human-made glass objects. Small, colored, opaque. Nothing like the clear glass we are familiar with. The earliest glass was typically blue-green, colored by copper impurities and completely opaque. It did not look like a window. It looked like a jewel. The chemistry of glass is straightforward. Silica, found in sand or crushed quartz, melts at around 1,700 degrees Celsius. That is beyond the reach of any ancient furnace. But add an alkali, plant ash, or natron, a naturally occurring sodium compound abundant in Egypt, and the melting point drops dramatically to around 800 or 900 degrees. Add lime for stability, and you have a workable glass recipe. The ancient glassmakers did not understand the chemistry. What they understood was the recipe: silica, ash, heat. The result flowed, cooled, and became something new. Something that could be shaped while hot and held its shape when cold. Something that caught and held light in a way that no other material did. The colored glass beads of ancient Egypt were precious, worn by pharaohs, placed in royal tombs. The material was rare, beautiful, and entirely controlled by those who knew how to make it. Glass evolved slowly over the following centuries. Core-formed glass vessels appeared. Rods of glass wound around a clay core to form bottles and perfume flasks. By around 50 BCE, glassblowing was invented, probably in the region of modern Syria and Lebanon, and the entire economics of glass changed overnight. Suddenly, glass could be produced quickly, in any shape, far more cheaply than before. The window glass that would eventually define architecture. The lenses that would power the scientific revolution. The fibers that carry the internet. All of it traces back to someone in an ancient furnace noticing something unexpected in the ashes. A strange, smooth, hard residue that caught the light. Melted sand. Changed everything. Like and subscribe if you enjoy these videos. I'll see you in the next one.